Hey, I'm just testing. Can anyone hear me?
Yes. Yes, we can hear you. So for those of you following along in chat and the announcement I made 5 minutes ago, Russ is apparently having audio issues. He was going to try to leave and rejoin to see if that would fix it. And I saw him back on here briefly, but I haven't seen him yet. So that's where we are. We'll give him a little bit, and if he doesn't show up relatively soon, we will just start the meeting without him.
Test 1, 2, 3, 4. Could you hear me now?
Yes, we can hear you, Russ.
Awesome. Okay. I rebooted. Don't ask me what happened in between. All right, let me get the slides up. Okay, Tim, if you would watch the chat, I can run the screen, and I have all the slides just in case the presenter is not able to share their screen. Okay, so we'll start with the chair slides. This is the LAMPS working group. Note well, remind you, everyone, that please don't contribute unless you've paid attention to this. And this is the agenda for today. It's been out there for a while with very few changes. Are there any agenda bashes? Okay, hearing none. Let's talk about the minute taking. We had 2 volunteers, thanks to Jonathan and Rich. They both said they would take notes in CodeMD. Hopefully between the 2 of them, everything will be captured. Of course, you can take a look there yourself to make sure if you make a point that it gets captured correctly. The blue sheets are captured automatically by joining the session, so you don't have to do anything for that. And we have 2 documents that are with the RFC editor. As a matter of fact, they're both now in Auth48, so we expect them to come out shortly. I am unaware of any open issues with them, given that they're at Auth48. There shouldn't be, but if the authors of those 2 documents, OCSP nonce and 730 clarify, are aware of any, please come to the mic and tell us about them. Okay, hearing none, we'll move on to the active working group documents. One presentation by Hendrik is going to cover the updates, the algorithms, and the lightweight Cmp profile. Hendrik, are you planning to share your screen, or do you want me to put them up for you? Great. Okay, so let me stop sharing. You should be able to
So so here we are.
Okay, so if you could get rid of the thumbnails on the side to make it bigger, that would help. When you put it in presentation, that is not the one that gets sent to Medico. The edit version is the one that gets sent. Don't ask me why on that.
Okay. I just put, so
Yep, exactly. Thank you.
this is the best side.
Okay, I will mute and turn it over to you.
Okay, so now it should work. Sorry for the confusion. So yeah, thanks for giving me the opportunity to give an update to the CMP related drafts. So since last IETF, I submitted a draft on Cmp algorithms as discussed during last IETF. This draft has probably the well-known structure like other documents, lists message digest algorithm, signature algorithm, a section on different key management algorithms for the envelope data stuff in the document. Content encryption algorithm also used only in the context of envelope data, and message authentication code algorithms. So I will briefly show what the status is. First of all, I focused on section 2, 5, and 6 from the document and had some rounds there internally. Message digest algorithms, I have only SHA-2 right now in the document, but I would plan to also add Shake. Is there any other suggestion from the group on adding further algorithms? So I saw that there is Blake 2 out there, but seemed not to be in the focus of IETF. So any feedback here on hash algorithms that should be covered?
The ones you've picked sound good to me. Anyone else?
Okay. If not, I'm fine with continuing on, and we anyhow have time on the mailing list to discuss if there are others. For content encryption,
You can't see the chat, I guess, but others are saying that looks good.
yeah. Thanks for the feedback. So regarding content encryption algorithms in the context of CMP, content encryption is only relevant with asymmetric key packages, providing encrypted certificates, and providing passphrase, revocation passphrases in encrypted form. So just very limited use cases for content encryption. And currently I have AES CCM and AES GCM in the document. I could add AES CBC or Cha-Cha 20, one as an older algorithm and one for the future. Let's say, is there any feedback? What is the opinion from the group here?
So I thought you were using envelope data.
Yes.
AES CCM and AES GCM both require authenticated envelope data, not just envelope data. So
Okay.
5083, RFC 5083 specifies authenticated envelope data, but RFC 5652, which is what I think you're using, only has envelope data. So I think you either need to do a bigger replumbing to support authenticated encryption, or you need to not use an AEAD, and so like AES CBC or something like that.
Yeah, so actually I guess we do not really need the authenticated encryption in this use case, as the envelope data package is part of a CMS message that is authenticated by signature or a MAC. So
that was my memory too. So you could get rid of the additional MAC capability if you had authenticated encryption, but it would require a bigger change to CMP to support authenticated encryption.
Yeah, not sure whether this is worth doing for this use case. So probably better to move to AES CBC.
That's probably a good plan.
Okay. So yeah, again, learn something about CMS. With regard to message authentication code, so from RFC 4210 and 11, we have these password-based MAC and Diffie-Hellman-based MAC. Even though they look somehow not that state-of-the-art anymore, we also have a draft from Russ on the password-based MAC definition in 4211. So I thought about offering alternatives like PBMAC1 from RFC 8018 for CMC use, even though I believe implementations will not move away from using password-based MAC actually. But in the context of other key management techniques, MAC algorithms are used, and also in the context of the password-based MAC, a MAC algorithm is used, and therefore we will also need to specify some regular MAC algorithms like SHA-2, HMAC, or maybe others. And that would be the question whether to add further MAC algorithms like AES GMAC. That was also a discussion on the list with regard to the update to 4211. And if we add shake hash algorithms, then the KMAC variant of shake could also be added.
So on that thread, people were not particularly interested in CMAC. So I would stick to either GMAC or the HMAC based on SHA-2. Those were the two that had the most interest.
Mm-hmm.
I remember Sean Turner speaking, and I know he's in a parallel session right now, so that's why I raised it for him.
Okay, is there a reason behind not having a CMAC, AES CMAC in favor?
Oh, there's no problem with it. It's just we're just seeing a lot of support for GMAC because it's parallelizable.
Mm-hmm. Okay. Good. So this is it. For the next slide, these are the sections I didn't look further into. So currently I have DSA, RSA, and ECDSA, all with SHA-2 in the document, and RSA, SSA, PSS in addition. I was thinking about listing some examples of curves to be used with ECDSA, like the NIST curves or newer curves like 22,519. What do others think? Would that make sense in this kind of document? I didn't see it in other similar documents yet.
Uh, 25519 is gaining support, and there is an RFC that says how to use it, I believe, that came out of the Kernel working group.
Okay. Good. So yeah.
Yeah, but it's not ECDSA with curve 22519. There's a signature algorithm called ED 25519.
Yeah.
Was that the stuff that came out of CFRG? Right.
It's the CFRG curve, but there is a kernel draft, I thought, on how to use it for CMS.
Oh yeah, you're probably right. Didn't win. Okay.
I think you chaired that.
I still do, as far as I know.
Okay, just
Yeah. Yeah. Okay.
okay.
Okay. So thanks for that. There was also some internal discussion whether to stick to listing DSA, even though it's not that widely used anymore. Is there any opinion in the group there?
I would advocate removing it unless somebody has a use for it.
Okay.
I guess speak up, please, if you have a need for DSA. Not hearing anything, so I would drop it and see if somebody pushes back. It's most people have moved on to well, bigger RSA keys or ECDSA.
Yeah. So that's also my impression, and therefore, yeah, we were thinking also about removing it.
Yeah, several people in chat want DSA removed as well.
Okay. Yeah, I'm fine with that. Okay. Good. With regard to key management algorithms, so this is just some first set I put together. As said, I didn't look much deeper in this. I was just thinking about whether to, yeah, not to list any static Diffie-Hellman variants here, as I believe in the context or in the kind of usage within CMP, within certificate management, it doesn't really make sense. So you should always have an ephemeral part. So if there is no one having a use case for static Diffie-Hellman variants, I would just ignore them in this document.
In the queue ahead of me, I would recommend not just ignoring them, but maybe explicitly deprecating them. If you're trying to write a profile for modern, crypto that you expect to be strong, I would just discourage them actively.
Okay. Yeah, as said, I also don't see use cases actually, so could also put a sentence to discourage usage of static. Good. For key transport algorithms, I just list standard RSA encryption and RSAES OPEEP. So
yeah, I've not seen any OAEP really implemented in the wild. Although it's a strong crypto, I've just never seen it take off.
Yeah, so I haven't seen it either. So I could also drop it. Okay.
Maybe, drop it, but don't unrecommend it like the other, like DSA,
Yeah.
ECDSA.
Just not mentioning it.
Yes. Okay. That works for me.
So anyhow, the focus of the document is to list some typical algorithms, but not saying you cannot use others. So anyhow, you can use whatever you think is reasonable for your use cases. Yeah. Good. For symmetric key encryption algorithms, I just list AES keyrep. And for key derivation algorithms, PBKDF2. So any further feedbacks on this status here? Okay, so I jump to the next slide. So on the status of Cmp updates, I think quite all of the updates discussed in IETF108 and in the subsequent discussions on the mailing list. So I added the asymmetric key package structure for centrally generated keys. I did some clarification on the usage of general message together with EC curves after discussion with Russ on the mailing list. I updated or I added the sections on the new general message types that are used in the lightweight Cmp profile, just to add the new part, the new OIDs and ASN1 syntax for these general messages, and the detailed usage is still in lightweight Cmp profile document. I also make use of the ID rec control controls from Crmf instead of RSA keylang variable in the certificate request template structure. I'll have further questions on that later on. I also updated the Appendix D2 of 4210 and just referred to Cmp Algorithms document for an updated list of algorithms, mandatory algorithms here. I also added the URI discovery part from the lightweight profile document to Cmp updates, as the usage of .wellknown is kind of changing the normative part of 6712. And yeah, did some discussion with Martin Paler also on this section. And I added the ASN1 modules and did the updates there. So that is what was done since last IETF. Coming to the root CA certificate update general message. This is a general message as it is currently specified, but after discussing this internally, we figured out that this exchange is unspecific on which root CA, for which root CA we are requesting an update. So currently, if there is a PKI that serves different root CAs, then currently we have no means to neither specify for which root CA we want to have an update, nor can the PKI respond with a set of updates for all of the roots it has. And therefore, we're just discussing about solutions, and our main suggestion was to just put the old with old, so the old root CA certificate into the request message, and then it is clear on what update is requested.
So you're just going to pass the what it becomes is this, are there any updates to this root certificate? Because it's not the old signed with the old.
So the old signed with the old is a current root CA certificate. And if we would put this into the request message, then the PKI knows for which root CA is the update requested.
If we're going to change that, don't we need to assign a new OID so that existing implementations don't choke when they get a root certificate there instead of a null?
So we introduce in Cmp Updates this OID. So this is new.
It is a new OID. Okay, thank you.
Yeah, as of today, we are free to specify it.
That if you're using a new OID, it's fine.
Yeah. So yeah, the question would be, would we then need a different OID for the request and the response message? But I thought it is okay to use the same OID here and just specify.
No, that's correct. It's the OID is used for both. Is the way I read the spec, but in the context tells you whether you're doing the request or the response.
Mm-hmm. Good. Okay, if no one objects against this suggestion, I would just update the draft accordingly and move to the next certificate, the next general message type, this certificate request template. We kind of have a similar issue here. So typically, we see PKIs where a CA supports different certificate profiles. So, for example, it's OPC UA certificates and TLS client and other certificates for maybe other applications. So one CA could serve different certificate types or certificate profiles. So if you send a request message to say, give me the certificate request template to a CA, then it may be not clear which template to respond. So therefore, we also thought about that we have a similar issue with sending a request message a certificate request message to a CA. If the CA supports different certificate types, it is maybe not completely clear which certificate profile to use on that CA. And therefore the question was, do we need, or how does other certificate management protocols handle this? I know that EST has a get CSR attributes message, but I'm not aware that there are means to differentiate for which template they request the attributes. So yeah, the question is, are there any ideas on how to handle this, or is there any best practice? And if not, we could think about adding some content on the requested certificate profile in the PKI header general info field.
I think a info type value is fine. Does anyone else have a thought? I would say go with that suggestion.
Okay, good. Thank you. So let's move on to the next. Generally, as shown on, maybe I jump back, as shown on this slide, we use the controls here. So these are attribute type value as defined in RFC 4211, and we use it. So they are supposed to be used in the context of certificate requests. Here we use it kind of in a different kind of context, and we had some internal discussion whether this is suitable here. And I just wanted to double check with the group whether it is okay to register new rec control types or OIDs for the usage in this certificate request template general message, or whether we should do it differently.
Does anyone think, can anyone think of a better way to do it? Yeah, I guess Ayanna's going to get some additional requests for OIDs. Go ahead.
Okay. So there was some discussion also in Brisky AE. Don't know whether Michael is there in the call. And we thought about how to make the discovery in the CMP, whether to go with well-known / CMP or just with well-known. So don't know whether the discussion in Brisky or Brisky AE is already concluded, or whether there is any guidance here.
Go ahead, DKG.
My understanding is that there are some strong feelings about how specifically to use .wellknown in within the IETF anyway. And I know that there are different drafts that do it in different ways. But Mark Nottingham is known for having some pretty strong opinions about how it's intended to be used, like not wanting predefined trees within .wellknown, but rather having a single point that then makes a reference to other endpoints. So I would make sure that you get feedback from people like Mark.
Okay, thank you.
In chat, several people have said use well-known CMP.
Okay. I think this is also the way I specified it as of today. But yeah, That was just to reflect the discussion elsewhere. Good. Yeah. Thank you for the feedback. As we also have an appendix on the new 2002 ASN1 module, to update that one from RFC 5912, should we also say that this draft updates 5912?
Yes.
Okay. Good. Okay. Yeah, so this first point we just discussed. The second point, as we said, we will continue on with the new rec controls. Russ, could you arrange for a pre-registration for these?
Let's get some agreement on the draft, and then we will get it posted and a little review time. And once it looks stable, I can help with that.
Yeah, great. Thanks. Yeah, the same with the other. Next point is also probably something when the draft is stable and will be completed. Good. So, of course, like always, any feedback to the content of the draft is very welcome. So, please let me know if you have any feedback. On the
from the chat, just a minute, Hendrik. From the chat, you may need to put in additional IANA consideration to register well-known CMP. And if after the reading, if you take a look at the chat, it tells you which exact IANA registry.
Okay. Thought of I had added this, but I will check the chat and see what the feedback is. Thanks. Okay, on the lightweight CMP profile, so there is no much work on the content as of today. I just moved some of the parts or changed some of the content with regard to updates of Cmp updates and with the new Cmp algorithms document. I also did some changes with regard to the new draft Russ submitted on Crmf algorithms requirements update. I did some minor editorial things, and the rest of it is more or less due to the discussion and changes to Cmp updates. So moving some of the parts to Cmp updates to get rid of ASN1 module in lightweight CMP and to make use of the asymmetric key package. And I think this is it, what was done since last IETF. The to-dos is that, of course, after the discussion on the support messages, I will revisit the CMP, the sections in the CMP lightweight profile. We had discussions, or while implementing, maybe some of you noticed that we submitted a lightweight CMP array implementation, kind of a, let's say, reference implementation on GitHub/Siemens. So if anyone is interested, you're welcome to have a look at that. And while doing so, we figured out that TLS SRP cipher suite is not available in JSSE. And therefore, we were thinking, are there any suitable alternatives that are more have more footprint in implementations, or whether how to handle certificate-based or shared secret-based client authentication in TLS. What is there any suggestion? Okay, so we also didn't figure out a better solution. So we'll see, and if there is nothing else, then we leave it as it is. We will have to do an update of the certificate request template in the appendix, and that is it for the moment. As well, I welcome all of the feedbacks you have, so please let me know. Okay, this is it from my side to the status of the 3 drafts on CMP. So I'm done with my presentation. Thanks.
Okay, and any additional feedback for Hendrik before we move to the next presentation? DKG is on deck then. So if you, Hendrik, could stop sharing your screen.
Yes.
We will. You're still sharing.
Yeah, I'm
okay.
issues with unsharing.
It's up top under your name. There's a little publish screen. You click it again to stop. Okay. Now we're going to talk about header protection. There's going to be a tag team on this one, I believe. Go ahead.
Can you hear me?
Faint.
So is my audio coming through?
Much better.
Okay, good. So this is Björn Hüneisen. I'm making this presentation together with DKG. Like, I will have a first section that is just like saying what happened so far, and Daniel will then take over and discuss some issues like more like what's coming from now on. During my part of the presentation, there may be clarifying questions, but not contributions for discussions. Those should be postponed to Daniel's section. Next slide. So what are the changes since last time? We had a lively discussion during IETF 108, and most of the feedback has been implemented, at least those cases that were not too complicated. This includes an editorial cleanup that was like, in particular, abstract and introduction needed to be rewritten, which was complained about for good reasons. Then we started to restructure it a bit regarding the definitions, for example, like we have now cryptographic layer, cryptographic payload, and cryptographic envelope. Those are now defined in another draft, and this draft is referred to. And regarding this other draft, the plan is to split the current header protection draft into a draft that only discusses header protection, which is the one we are discussing. And then there's another draft, it's also on the agenda on the next point, if I correctly, that discusses general E2E mail guidance. We figured out that there's much more than header protection to make this stuff secure and private. We dropped the encrypted only messages case, as well as any other cases that are not signed only and signed and encrypted. And we updated obfuscation recommendations as per mailing list. And as I mentioned, DKG is now a co-author, and the draft will substantially change in the next version. Next slide, please. So the issues we discussed last time are just going briefly through that you know what the state is after the last discussion. These backwards compatibility things are still open. Protection levels is closed as we are limited to signature only and encrypted and signature, or the other way around basically. And on the receiving side, we may need to document other use case. Basically, this is a different story than the sending side. Then the MIME format is still open. We will have a discussion in the next section of this presentation. Next slide. Then we also changed the obfuscation header fields. We took out suggestions for obfuscating date, from, to, and all the stuff. And what's left is subject and message ID, though message ID is still under discussion, and this will be discussed in the next part of the presentation. Rendering messages. So far we discussed that we render the inner message only, or like the cryptographic payload, or whatever is it in the new terminology. But some additional information should be made available. How we do this, it's not yet clear, but this will be a thing that is discussed in the other draft, the guidance for end-to-end encryption, if I'm correct here. Then we had some discussion about the Bcc handling, and we can close this one because the text regarding Bcc will be kept minimal in this document, and we will refer to other documents. That was my section. Are there any clarifying questions? Clarifying questions only. If this is not the case, I'll hand over to Daniel.
Thanks, Bernie. Can folks hear me okay?
Hear you fine.
Great. So Bernie and Alexei and I have worked a bunch on this draft in the meantime, and we're gonna try to tighten it up. The main goal is to get it to focus on implementation guidance. I think the issue that we really want is we want this to be to provide a set of pretty clear instructions without too many choice points for implementers to just walk through and say, am I doing these things? Yep, I'm doing them. Okay, we're good to go. One concern that is raised here is, the user agent implementers are going to be dealing with arbitrary messages that are out there, and some messages are going to be in possibly different forms, because there are two main schemes of header protection that are found in the wild. And we've talked about this in previous versions of the draft. And ultimately, implementers are going to want to be able to deal with either scheme that they encounter. And it turns out the schemes are not that different, but they are different. They're subtly different. One of them I'm referring to in this as wrapped message, which is what was specified in SMIME 3.1. There are some implementations out there. There are some messages that are wrapped in that way. And the other form is injected headers, which was also known as this draft autocrypt protected headers, or the memory hole specification. There are messages of both forms that are out there floating around. So we think that actually this draft is going to need to give you guidance as a receiving mail user agent as to how to implement them, how to interpret them. It also needs to give guidance about how to compose them, although maybe we only need to give guidance about how to compose one of them if there's a clear choice for what we think implementers should do. That's an open question. I'll talk about that in a second. Also, as you're encrypting a message, there's this question about how do you obscure the headers that are going to be covered by encryption? I'm proposing here a formalization of that called a header confidentiality policy to make it easier to talk about. And again, I'll get into that in a little bit. I also think that the draft is going to end up growing a bunch of test vectors and some analysis and comparison of the different mechanisms available. So the two main open questions that we have that we definitely need working group feedback on are which header protection scheme. So first off, the open questions in terms of implementation guidance are about message composition. That's the time when you really have choice points, right? An implementer who's receiving a message basically has to know what to do with the message it received. But when it's emitting a message, there will be some choices to make. And we think that the draft should give clear guidance about what to do. And so the two main questions are, which scheme should you use when you're composing a message with header protection, and what should your, if you're doing an encrypted message, what should the header confidentiality policy be? So I'm going to go into those in a little bit more detail, a couple slides on each one. And so, I'm going to be posing specific questions here for the working group. Obviously, this is going to be taken up on list eventually, but I don't claim to have answers to these things right now. They should be pretty straightforward questions, but the answers are not clear yet. I have a proposal about ways we can think about this, ways to go forward, but no specific answers. So I just want to highlight this because this is the open questions that we'll be working on as the next revision comes around. So here's the two header protection schemes that are out there. On the left, we have the wrapped message, which uses this message RFCA22. Some of that, this forwarded equals no tag, I don't know if anybody was at dispatch earlier this week, but it was discussed. Maybe it's not forwarded equals no, maybe it's some other mechanism. But basically there's this one wrapping part, and then there's the embedded part that has the headers. The bold in this diagram shows you where the protected headers live within the cryptographic payload, right? So this is, here, regardless of what kinds of cryptographic protections are in place, you have the cryptographic layers on the outside, those form the cryptographic envelope, and then the protections arise because the headers are present inside the payload. And in wrapped message, they're in part B there in this diagram. The other alternative is injected headers. And just look at the top one there for a second. It looks an awful lot like wrapped message, the only difference being that there isn't this wrapping layer. And there's a different content type parameter that's supplied. Protected dash headers equals v1 is the structure that people are using on the network today. But basically, it's the headers live on part D, and they live on part D just directly inside the cryptographic envelope. There is a weird corner case for an encrypted message that's being sent to a client that isn't going to be able to read, that isn't going to know about injected headers. And that adds this legacy display part, which is a way of just sort of stuffing an additional text part that includes the headers that you would think that a legacy client would want to know about, so that, for example, so that you don't hide the subject from them. The person who's reading the message can still see the subject even if it doesn't sort of land in the right place in the mail user agent. So it's really only this with legacy display is a bit more complex as a structure, but if you look closely, you'll see that I, J, and K in that legacy display are the same as D, E, and F in injected headers. And it's just about using multi-part mix and a text plain part to stuff an additional display field. The idea is that an implementer who's receiving messages that look like this can detect that that's a legacy display part and avoid rendering it entirely because they already know that they get the headers from the right place, which is part G or part D in the without a legacy display. So those are the two schemes. And then the question is, how are we going to choose at composition time or at implementation time which of the two schemes we're going to recommend? Maybe the draft should only recommend composing one. And I'm proposing this particular analysis matrix to do that. So what you're seeing here is a chart that I'm proposing that we need to fill in, hopefully as a group, that describes different scenarios for message composition and sending and receiving to think about the header schemes. So the vertical axis here is protections, is what kinds of protections you're applying to the composed message, right? Is it signed? Which type of signature form is it? Is it signed and encrypted? As Bernie mentioned, we are not going to deal with a case where you're just sending an encrypted message. We think that the draft should encourage basically only one of two choices, signed only or signed and encrypted. On the receiving side, of course, lack of signatures or signature validation failures mean the receiver is going to need to deal with messages that are encrypted but have no valid signature. But at the generation time, there's only two sort of choices, signed and encrypted versus signed only. Of course, there are two different kinds of signed only in PKCS7. But anyway, the horizontal axis here is what we think the recipient mail user agent can do. Now, obviously, if you're sending a message to multiple mail user agents, they've got different, they might each have different capabilities. But we'll just think about the case where one recipient is looking at the message. And I've divided here the categories of recipient into three buckets. There's the folks that fully implement the header protection scheme that we recommend. That's the green columns on the right. And we want to think separately about how do these mail user agents render the message, and also how do they behave when you reply to the message, because that might be different as well. And so in the yellow column on the left, we're talking about mail user agents that are legacy clients that have no crypto capabilities whatsoever. And in the blue, we're looking at legacy clients, legacy just meaning they don't implement header protection, but they do have cryptographic capabilities already. They have the standard cryptographic capabilities, but they don't understand this header protection thing. I think that's the majority of all the mail user agents that have crypto right now. And so those 8 boxes that are in there that are unfilled in, I think are the things that are going to make a difference, because the ones that are already filled in should be the same regardless of header protection scheme, right? You get unreadable messages in the 4 boxes in the lower left. Everything is perfect on the right in the green. And so we really need to think about those 8 boxes here in the middle. So I don't actually have the answers for what this looks like, but I'm just framing this as how I think we should be evaluating which header protection scheme to use for message composition. If people have concerns about this as an evaluation scheme, where they want to suggest additional nuance, I'd be happy to hear it, both now and on the list. But just so you know, this is sort of where I'm thinking we need to go to evaluate which scheme to recommend. So not seeing anyone in the queue, I'm going to go ahead with the next section. So that was header protection schemes, different header protection schemes. And then this is this header.
I would like to ask if anyone disagrees with this approach, please speak now.
Yep. Or raise it on the list, but raise it soon.
Right, but real soon.
Yep. Because we want to keep going here. And you know,
Indeed.
obviously, if we complete this analysis and there's no clear answer, then we're going to need to figure some other way to carve it up.
But let's get the data right.
Yep.
Okay. I'm not hearing anyone think this is a bad way to explore the problem.
Cool. So this may mean that I ask you on the list to like try out the mail user agent that you work on, or old versions of the mail user agent that you work on, or the mail agent that you use. And if you want to just give some feedback, say, hey, I tried and it looked this way. It'd be cool to get that from people on the list. So I hope people will consider doing that. So moving on, this header confidentiality policy is a formalism that I'm proposing here so that we can talk about what it means to protect headers of encrypted messages. So this is not about signed only messages. We're just talking about messages that have a layer of encryption. We don't actually believe that we can give all of the headers of the message the same protections that the message body has in terms of confidentiality, because there may be routing issues or spam abatement issues or whatever. So the question becomes, how do I choose what to put on the outside of the cryptographic envelope, given what I know is going to go on the inside as I'm composing it? And so this is a simple formalization, which is we're defining the header confidentiality policy as a function that takes the name of the header and the value of the header as it looks on the interior of the cryptographic envelope, that is in the cryptographic payload, the protected header. And we're going to map that to a value that goes in the output. And if the value that goes in the output is a special value null, then that means we won't even bother putting it on the outside. So this is just a simple way that if you're an implementer or you're a researcher, you want to document how header protection can work or should work in the future, you can say, hey, here's the new header confidentiality policy, the new HCP I think we should use, and we can test that. I want to be clear that for this particular draft, I hope to recommend one particular HCP by default. And the idea of declaring this HCP formalism is that future drafts could propose new ones, and we can talk about what the consequences of those things would be while having a very concise summary of what the actual proposal under discussion is. So let me just show you 2 example HCPs that I think are candidates for what we recommend here, but there are obviously, this is a function. The function space could be arbitrarily large. There are other ones you could imagine, but here's 2 to consider. So the first one on the left is called, we just named it HCP minimal. And it basically says, we look at the headers that are going to go on the inside of the headers that are going to get on the cryptographic payload, that is inside the cryptographic envelope. And for each of them, we're just going to copy it to the outside. So we're not going to give any confidentiality with the exception of the subject header. And if it's a subject header, we're just going to replace it with square bracket, dot, 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 square bracket, the literal string. So this HCP minimal basically says, protect the subject as though it were part of the body, but otherwise we're not protecting confidentiality of anything else. So that's one. And the other one is this HCP strong. And this one is a little bit more nuanced, and it's a little more privacy preserving, but may have other issues. It basically says, if the header is from, to, CC, or date, then we'll map it to the outside. If it's a subject, we obscure it in the same way that HCP minimal obscures it. If it's a message ID, we're going to generate a new message ID on the outside. And all other headers, we're going to completely strip. So there will be no other headers as the message is, is injected into the mail system by the mail user agent. There will be no other headers on the outside besides from, to, CC, date, subject, and message ID, where subject and message ID are obscured in the ways defined here. This function, new message ID, just means however the mail user agent would generate a message ID, just do it again. So you've got one on the inside and you've got a different message ID on the outside, and everything else gets stripped. So these are two sample HCPs. Does anyone want to ask questions about this particular formalism? The goal is to make it pretty concise to describe what it is that a user agent is going to do. So I hope it's clear there.
So I really like this. And
in the chat. Okay, I see one hand from Bernie.
Tim kind of got cut off there. I don't know if he was saying something.
I was going to, but Bernie can go first.
Okay.
Okay. Well, for me, this interesting thing would be how much do we lose if we make the header protection strong? Like we lose a message ID, which is used for IMAP server threading and like kind of aligning messages to each other. For me, the open question is still like, is this really a useful feature if we have encrypted messages on the outside that we can thread them? And what are the use cases? Like you probably have some more experience with that, like you as a crowd here. Are there any answers to that questions?
I'm not hearing any. So.
Russ, sorry, I just put up the hand. Maybe can I just speak quickly?
Sure, go ahead.
From me being both a SMIME implementer as well as I'm a client implementer, the positive thing about threading, you can thread messages without downloading them in full. So not being able to thread them would, if you have to download all the messages before you can thread them, that's way more bandwidth, way more CPU power and stuff like that. You might agree or disagree with this goal, but this is basically the advantage of this approach.
Anyone else with experience they want to share?
The only other thing the
Sorry.
only thing I wanted to mention here is I may be showing my former mathematician roots, but there's an implicit assumption here that your HCP function works on a header by header basis. And I think it's a correct assumption that there isn't a HCP we'd want to think of that doesn't work in that manner. But that's one of the drawbacks of this mathematical model that you have here.
Yes, so there's a number of sort of sneaky implicit assumptions in the HCP as it's defined here. And if we find that those assumptions are problematically wrong, I'm fine with trying to refine how we declare an HCP. In addition to what Tim mentions, it also the function has the benefit of being sort of stateless, in that it's probably not supposed to like keep track of what other scrubbing it's done. It doesn't appear to be ordered. It doesn't appear to have, there's no other inputs like other special information that maybe the header, maybe the mail user agent happens to know at message composition time. So it is actually a fairly constrained space to do the reasoning about. And if people come up with proposed HCPs that require a different function signature, then, you know, we can talk about them. And we can talk about changing the signature of it, just, you know, like new inputs, right? Like a user flag that says, do this and that. But I think that trying to keep it as simple as possible in this initial version so that we we have a clear thing that we can suggest initially is going to be a useful approach. We're going to probably try to do a call on the list for people's feedback about what they think the default HCP should be in this draft. But I really don't want us to get super bogged down on that question, because I think that we don't actually know. I think the goal of this draft in general is to declare a mechanism and get people to implement the mechanism on both sending and receiving sides. And then we'll actually have the ability to experiment with additional HCPs. And I think follow-up drafts can cover that. So anyway, you know, I'm just raising the point that we do need to make a decision about this draft. I only want to recommend one, because I want this draft to basically be something where an implementer can just go check stuff off and not have to make any hard decisions. One additional note about the HCP, which is awkward, is that the implementer of the HCP is the sender, but the person who's affected by it in terms of server-side threading, for example, is the recipient. And it's possible that you need some sort of, I don't know, signaling mechanism between mail clients that says, I'm fine if you want to use HCP strong, for example. So again, I would imagine that being future work, not part of this particular draft. But you know, the draft is suggesting that the sender, I think this is just the state of play in email, the sender is going to have to make some decisions on behalf of the recipient.
So that was the kind of reasoning that led to SMIME capabilities.
Mm-hmm.
You know, what encryption algorithms do different recipient support that the sender could learn over time to know which algorithms for which collection of recipients to use. And we haven't seen that really has influenced the sender's choice in encryption algorithm. At least, you know, it hasn't been the wild success that we hoped it would be. And other things that were put in there are like whether compression was supported, and stuff like that. So I'm just not sure whether adding a clause to the SMIME capabilities for which HCPs you prefer would be any different than what you just suggested.
Yep, and I agree with you that sounds like the most plausible place to do it. I also agree with you that I have no idea if it would work.
Okay.
But I just want to say that we don't need to do that for this draft, and I hope that we don't try to get into that for this draft.
I just wanted to note the parallel for the way people think about it.
Yep.
Alexei, is that a new hand or an old one?
Old one.
You can unqueue yourself with the same button you used to enqueue yourself if you want. Okay, so I just had one more slide here. Sorry. So in the course of trying to tighten this draft up and make it a clearer set of guidance for implementers, I actually realized that there are some interesting subtleties. And Russ, feel free to yank this because I could go far over time in all of the like weird details and corner cases that came up in this discussion. But just to identify a couple of interesting ones that came up around the header confidentiality policy question. and this is something, again, we may not solve in this particular draft. I just want to give people a heads up. If you're a mail user agent implementer and you're thinking about these questions, I'd love to hear your feedback on how you would solve the problem. But so here's an example. The sender, you receive a message from someone who used a stronger HCP than you would use by default. When you reply to their message, you're going to stuff some stuff in header fields that they would have obscured, but you didn't. Now, we all know that replying to an encrypted email in the clear is pretty bad form, and you don't want your mail user agent to be the one that does that. So how do you adjust your HCP if you receive a message from someone with a stronger with a stronger HCP than you have? How do you avoid, like, say they protect the say they're using HCP strong and they strip out references and then reply to, and they mangle the message ID, but you're used to just using HCP minimal. Are you going to end up leaking all of their references tags that they avoided leaking before? Like, that's a little bit weird and awkward. Another point, you can imagine some HCPs that subtly obfuscate a field, not completely, but for example, when I send a message, my date exposes my system's time zone. And I don't need to do that. Why do I need to expose that on the wire? Maybe I want the recipient to know what time zone I'm in, but I don't want the mail transport system to know what time zone I'm in. So maybe I have an HCP that takes the date and just translates it to GMT, or UTC, or whatever we're calling it these days, right? Or maybe it takes the email addresses that are in the to and the from headers, and it removes all the display names and just puts them as raw email addresses in those headers, right? So these are subtle obfuscations. They would show up when you're looking at an email. They would show up as being things that don't match. The outside of the envelope doesn't match the inside of the cryptographic envelope. It doesn't match what's on the inside. But it's not like it's fully confidential because the actual date is still there, just the time zone's gone, right? Or the email address is there, but the display name is gone. And so there's like a user interface and user experience question about how you identify to the user that a header might have been obfuscated or might have been partly obfuscated. That I think is a real challenge from a usability perspective. And it's also a challenge in terms of when you're looking at a message and you're trying to decide how to reply to it, which headers do you want to make sure you obfuscate and in what way, so that you don't end up leaking more of the information than came in. And Bernie already mentioned questions about what is the impact of header confidentiality policy on IMAP threading, IMAP header search, server-side spam filtering, and things like that. So these are just some wrinkles that we're going to need to grapple with if this thing actually gets traction, which I hope it will. But I wanted people to have it in mind. Bernie's in the queue. Bernie, you want to speak up?
Yes, just a remark regarding this header confidentiality policy strong. It's basically what we have implemented at PEP, and we are only using the inner message and leave the outer message out. But sometimes comparing the outer and the inner side may be confusing, as you mentioned. But I don't see a problem with the HCP strong in the implementation wise. Question is only like what we do with implementations that do not implement it correctly and start to leak data.
Yeah, so I want to be clear. When you say that what PEP only uses the inner layer and leaves the outer layer alone, one way to interpret that would be that you're talking about how you receive a message, right?
That's
and I want to be clear
yeah.
that HCP has nothing to do with message receipt, right? We have a
Well,
standard
it
set of rules.
Yeah, I agree to that.
Well, but so the way the draft is written, there are no decisions to be made at receipt time. We had the draft outlines a deterministic set of ways to handle the message, and of course, implementers who haven't implemented the draft won't do those things.
Yeah.
But there are no choices to be made at receipt time. It is an unambiguous mechanical process. The only choices that you have are at sending time, and that includes so the tricky bit, of course, is sending time that involves a reply, right? That's where the subtleties really get tough. But just to be clear, like when Bernie's saying that PEP has implemented this, I think what you're saying is that PEP is implementing the HCP strong for sending time, And maybe that means, Bernie, that you can report back with some data of what your experiences are in terms of sending messages like that to users that have mail user agents that fall in one of those different categories that are outlined in the in this evaluation slide, right? Just so we can talk about and reason about how that goes. That kind of data would be really useful for us.
Yeah. Like, first of all, I was referring to what you said, that the sender makes a choice that has an impact on the receiver. That was basically the comment about. So of course, this is on the sending side, but it impacts the receiver. And what I want to say, we have a system in place that didn't cause any of these issues that we observed. That doesn't mean that they don't show up with other implementations. But that's all what I said. And yeah, we can share the experience if that is needed or if that is useful.
Great. So I think that wraps up this presentation, unless other folks have comments. Hearing nothing, I will stop sharing that slide deck.
Okay, I think you want to, at this point, we're moving on to prospective work. Each of these has been talked about a little bit on the mail list. The first one is the end-to-end mail guidance. And when this thread started, DKG observed that we probably would have to recharter to make sure this is within scope. And so I just wanted to preface your presentation with that, making sure that was in everyone's mind. Okay, go ahead. You let go of the screen. Okay.
Well, I'm changing. I'm sharing a different.
Yeah, I get it.
Window here. Let's see here. How does this work? Something like that. Yeah. So thanks. I'm back. So I don't actually think, Russ, that I intended to say that we must recharter. Just that it occurred to me that maybe chairs think we should recharter. I proposed a little bit of, oh no, I think the guidance I proposed was about the sample certificates. Anyway, I'm fine if we need to recharter to do this. Like, that doesn't particularly bother me. I will write up some text if people think that's useful.
Yeah. I thought you proposed one, but regardless, what we have to do is look at whether the header protection work item encompasses everything you want to do here. So one alternative would be to put more flexibility in that work item if it doesn't, and the other would be to add an additional work item.
Yeah. So the reason that I split this out was because I think there's actually general guidance here, even for folks that are not doing header protection. And so lumping this entirely under header protection seems like it might be a mistake, because I suspect if we can get a quorum of implementers actively talking about this, I think there's a lot of room for people to share observations that they have or subtleties for their clients. And in fact, there are some researchers who've done a bunch of really interesting stuff recently. I mean, even the eFail folks, who I would love to hear their guidance that has nothing to do with header protection, but how to do, how to deal with other particular kinds of problems. So let me just give you a quick sense of what's in the current draft. So it's got like these concepts like cryptographic envelope and cryptographic payload, cryptographic layer, which we're using in the header protection work. But those, I think, are useful concepts just for thinking about how you present a message and how you compose a message as well. It tries to outline what user expectations are for end-to-end encrypted email. For example, users are looking for things that behave like email. So if you propose something that's going to give you end-to-end encrypted email, but it breaks a lot of things that are sort of standard email features, maybe this is not the right place to do that work. Maybe you need to propose a new messaging system or or some other platform. It's intended to provide pretty straightforward guidance for like, here's how you compose a message, here's how you interpret a message, similar to the way that the header protection stuff works, but not necessarily about headers, right? Just like when you're composing the message, you know, how should you think about structuring it? What kind of indicators should you give to the user? Those kind of things. And then room for other pitfalls, concerns, like common traps that you find yourself running into. And then also test vectors. Like I'd love to see some examples of, here are some messages that people typically have received, and here's how people might want to think about interpreting them. So some examples, specific examples of the types of things that are in there, right? Like encrypt the entire message, encrypt the entire MIME structure. Don't have some subparts that are encrypted or protected in one way and other subparts that are protected in a different way. Don't render a failed signature, similar to the guidance that's in DKIM, right? Like, let's not treat a failed signature as worse than no signature. Just don't render it if it's not there. Of course, that's, maybe this is controversial. Maybe we should take that out. This is my perspective right now. If the working group does pick this up, I would expect to try to get working group consensus on this stuff. As Bernie mentioned earlier, like we're encouraging people not to send encrypted but unsigned messages. It's just a corner case that causes weird rendering problems on the receiving side, so forth. So this is the kind of guidance. If you ever worked on a end-to-end encrypted email client, you probably have a list of things like this in your back pocket that you ran into, that you stubbed your toe on, or even just as a user. It'd be great to try to work some of those things in here in a way that is actionable by somebody who's implementing. So if you're interested in this, read the current draft, contribute suggestions. There's a bunch of to-dos there, and you're welcome to just like pick one of those out of the to-dos and try to implement it. I'm currently working on it in Markdown. This is the URL for it here. It's GitLab DKG E2 email guidance. Note that that's GitLab and not GitHub. If that's a problem for you, let me know. I can mirror it someplace else. But I prefer to keep working on it in Git with people, and I welcome merge requests or pull requests or whatever you want to call it. Patches to the list are also fine. So I would like to see LAMPS adopt this. If that means rechartering, I'm fine with that. I'm fine being an editor for it. If anybody wants to co-edit with me, that'd be great. If anybody wants to replace me as editor, that would be super. I'm always happy to have someone else do the work that I thought I would have to do. I just think that we as implementers and people who care about protected email should be trying to talk to each other about the expectations that we have. So that's the short run there. If folks have comments, I'd be happy to hear them, and also happy to hear stuff on the list.
The high level question is there anyone who thinks we should not do this work?
So for example, if you think that any thoughts about user experience should be off limits to the IETF, you should speak up now, because I warn you, this draft is going to talk about user experience. Happy to see no obvious objections, although maybe the fact that maybe the hour is helping to keep the complaints down.
Indeed. So we will continue the thread on the list. I do think if you don't want to couple this with header protection, some words about interoperability end-to-end are probably going to be needed in the charter. There are some things there that regarding header protection, about increasing security while maintaining interoperability. But if you don't want to couple with that, this is really about user experience and interoperability.
I would agree with that, Russ, and I'm happy to propose an edit to the charter that would make this in scope.
Okay, I noticed that we don't have our AD with us right now. No, we do. Roman, any concern with that?
I don't have any concerns. Generally, I know there's always a tension with how broad and how specific we do things in this working group. I'm in favor of always a little more general, so we don't have to constantly recharter. And I'm good with the UX because that's the whole other part of security.
Okay. So why don't, as a next step in the thread, DKG, why don't you propose that broadening of the charter, and that will guarantee that if there's anyone who is not happy with this work, they will speak up.
Yep.
Okay.
I will do that.
All right, great. If you could stop sharing your screen. So I'm going to talk briefly about the Crmf algorithm update document. The goal of this is to update the cryptographic algorithms for the password-based MAC in Crmf, which is RFC 4211. The problem was discovered by Hendrik when he was working on his algorithm document. And I noticed he was pulling in a bunch of really old algorithms, and he said, oh, I have to because they're needed for this password-based MAC. What he was talking about was, if you go there and look at section 4.4 of Crmf, you'll see that it must support SHA-1, it must support HMAC SHA-1, it must support DES-MAC, and it must support triple DES-MAC. Well, the idea is to replace those choices with something that's more modern. And so the proposed replacements, after a little bit of discussion on the list, are the mandatory to implement being SHA-256 and HMAC SHA-256, and a should AES GMAC. And my 0.0 version of this had CMAC there. That's what led to the comments earlier that GMAC seemed to have a little more support. So the way forward would be to do a working group call for adoption. I think this fits within the current charter about supporting modern cryptography. Of course, since I wrote this draft, Tim will make any consensus calls related to it. Are there any concerns about moving forward with this? Looking for, not seeing any hands, not seeing anything about this document in the chat. So Tim, I would ask you to start the call for adoption on this one.
All right.
Okay. Now, wrong. Okay, so it turned out that when I went to write the section in the document that we just discussed for how to do GMAC, I could not find an algorithm identifier for it. So I asked Quinn and Tim Polk to look at that, and Quinn came through and assigned one for it. So The simple goal of this document is to move forward and put out the ultimately RFC that defines those algorithm identifiers and the associated parameters. So they were assigned for the 3 AES key sizes, and the parameters are all the same for all 3 key sizes. Basically, you need a nonce because that's the way GMAC works. It's essentially an IV for the MAC function, and you can get a resulting MAC that is either 12, 13, 14, 15, or 16 octets in size. So in order for the previous document to work, we need this one. Tim already started the call for consensus or adoption on this document. And in fact, it will end a week from tomorrow. So if people have any concerns with this, please speak up on the mail list and we'll address them. Are there any concerns or questions about this? Okay, I see some support in the chat. I see no hands. So I think I'm done. This brings us to the end of the agenda. Are there any other topics we need to talk about today? All right, seeing no hands, I think we're done. Thank you very much to the note takers. I've jumped over a couple times to look at the CodeMD. Looks like you guys did a fantastic job. Thank you very much. And enjoy the rest of your IETF. Thank you.